Okay. Good morning. Good morning, everyone. Um, let me introduce myself. My name is Bhuvaneshwar, belongs to CSCA section, and you can see my roll number on my screen. It's 527, and in this PPT, we are going to talk about the topic. In this tech talk, I am going to discuss about the topic called Thevenin's and Norton's equivalent circuits. And this tech talk is from the subject analog and digital electronics. This is the brief introduction and the topic which I chosen. We will drive into the PPT now. Like first, before introducing that whole topic, let me give a brief introduction about what is the Thevenins and what. Wait for a second. Meanwhile, let me repeat. Yeah, yeah. Now the I think so. Screen is clear. I think hope so. Yeah. Let me deeply diving into the topic. Let me define you what are these Thevenins and Nortons. Basically, Thevenins and Nortons theorems are these are one of kind of theorems or procedures which we can think of. Like if you have a complicated circuits, like every circuit need not to like simply if you see mostly the circuits, if you see the mostly circuits will be here the resistor and here the voltage source and here the current, right? So in like it is a simple circuit. What if the circuit is like this? Here and here the one resistor and here another resistor and one more resistor and the voltage source here, and here again the one more voltage like this, or like two voltage source and many resistors, right? You can consider any kind of 2 ohm resistor, 3. Like if you want to find the current here or the voltage current here, it's made difficult by using just an ohms law, right? So to find the voltage or current at particular point of this particular part of the circuit, we have many procedures. One of them are Thevenins and Nortons. Thevenins and Nortons are used to find the voltage and current passing through a particular point by using a simple methods instead of doing it complicated. There are many limitations for Thevenins and Nortons. We will discuss in the PPT while discussing both the theorems. This is the brief, like what is the basic meaning of Thevenins and Nortons. Now we will go into the topic. Yeah, yeah, you can see here Thevenin's theorem. Let us consider the figure which I given here. See, in the figure you can see this is the network 1, this is the network 2, which are connected by A and B point, like those two are wires. Here the network 1 is a circuit which you can assume. Even the network 2 is circuit, like that circuit it can consist of any number of resistors or battery or any number of switches, or like what are the major essential parts in the circuit, right? We can consider any number of like network, and you can imagine of as two resistors and one voltage source and even the current source. Here in this video I am going to represent current source as this straight up arrow and circle, and the voltage source as V plus or minus. These are the representations, and resistors are represented by like simple wave kind of strikes, and battery or voltage source or battery, anything we can call it, it's represented by plus and minus symbol. These are the basic notations. Even any circuit network 1 consists of any number of resistors, voltage source and current source you can think of. Let us consider this network 1 and network 2. For purpose of discussion at this point, we consider the both networks are composed of resistors and independent voltage source and current source. If the circuit let me discuss. Circuit means we can it may consist of many independent current source or dependent current source or dependent voltage source or independent voltage source. Before, let me give a short introduction about the independent and what make the difference between the dependent and independent. Like dependent means if you consider a part of circuit, here the resistor is there. Suppose you think of here one voltage and here one more voltage. If one part of the circuit, here the voltage or current which passing through this part is dependent of another part. If it's the current or voltage passing at the one part of the circuit is dependent on the another part of the circuit, then we call it as an dependent. If it doesn't depend on another part of the voltage or current source, then we can classify it as an independent. This was the make the difference between the dependent independent current. Even we can consider voltage source and current source. This is the major difference which makes the difference between current and voltage source. Let me okay, you can consider the circuit network 1 and network 2. Please remember, for a short span of time, please remember this circuit. Yeah, now just detach the network 2 from network 2 from the circuit, then you are remaining with the network 1 which are connected to A and B. Now to find the Thevenin's voltage at point A and B, connect here a voltmeter. You can call it may be range from any parameters. Consider a voltmeter and connect at A, B and measure the voltage now at the A and B. Suppose this is the network 2 is detached from the network 1. We focus temporarily on only network 1. Network 1 can be accommodated in structure as we can imagine, maybe 45 like network as I discussed before. Here the mesh means a circuit, a circular circuit. Mesh means nothing but a circular circuit. You can consider it, but it should have a single voltage source or single current. That is the basically mesh. And mesh can consist of network can consist of resistor or any kind of thing. Let it be. Now place a see. Now place a voltmeter across A and B and read the voltage here. Like place a voltage meter across, then it will be a closed circuit and measure the voltage there. No matter how complicated network 1 is, we read one voltage. Like you can have any how complex the voltage complex is, can have many current sources or voltage sources. The voltage which we read the value will be only one. Like it may be even a positive voltage or negative voltage. If you are getting the voltage it as a negative, just reverse the voltmeter terminals, then you can get a positive. It doesn't matter, but the magnitude of the voltage will be the same. Whether it be positive or negative, the magnitude will be the same. Remember the point, the magnitude, whether it positive or negative, the magnitude of the voltmeter will be the same. Now we can call this voltage, like which we read now across the terminal A, B, we call this in Thevenin's voltage. Now deactivate all the sources of network 1, like deactivating all the network 1. If the voltmeters were there, then replace them with a short circuit. If the current sources are there, replace them with a open circuit. Let me suppose this is the circuit. Here the current source is there, here the voltage source is there. Suppose deactivating the voltage source mean that open circuited, like short circuited. Short circuit means just replace it with a wire, then it will like current now is freely to flow, like the resistance will be 0. If you in case of short circuit, the resistance will be 0. What does it mean by open circuit? The open circuit, you can think of this cutting of a wire, then the resistance will be tends to infinity. Approximately resistance will be infinite. Like if resistance is infinity means like current passing through 0, right? Then we can call it an open source. Just replace the all voltage sources with an open circuit and all current sources with an open circuit. Voltage with an short circuit, sorry, voltage with short circuit and current source is with an open circuit. Then now let me erase the screen. Yeah, as they now discuss, this is the story. We now deactivate all sources of network 1. To deactivate the voltage source, we remove the source and replace it with a short circuit. We deactivate the current source, we remove its source with an, just to remove the circuit. There will be no need of even removing, just remove the, like it's looked in the white spot cutter. Now yeah, this is the example. Now basic idea was make sure that whole network consists of only 1 volt voltage source and one resistor. Then by making various procedures, just make the circuit with only 1 voltage source and one resistor. Then it will be easy to find the Thevenin's voltage and across various parts. Consider the following circuit. As you can see on my screen, consider the following circuit. Voltage V1, V2 and the R1, R2, R3, I2, R1, and these are the various components which I mentioned here. Yeah, here the voltage V1, V2 and I2, current source I1, R1, R2, V3. These are various components. A typical circuit with independent. So these all are the independent circuit sources. How do we deactivate the source of the circuit? When the sources are deactivated, with the circuits appears like all here. See, you can compare here. If voltage let me see, this voltage source and this voltage source are replaced by an here this voltage source and this source replaced by open circuit. This current sources are replaced by an short circuits. You can see it of here. Yeah, these are replaced by an short circuits. See, when the source is deactivated, circuits appear select. You can see on my screen the red slicer is open circuit and the green lines are now short circuited. It's now clear, I think so. Now replace and now place an ohm meter across A and B and read the resistance. Like if now place the instead of calculating theoretically, let us use an device now and calculate the Thevenin's resistance here across A and B. Even if you perform a theoretical calculations, now you can think of it as an this is an parallel circuit. See, let me. Yeah, now you can, if you want to calculate theoretically, this will be an, like you can consider it as an these two are in series with in parallel with this, and this two and this whole circuit is in parallel with this, and you can find the equivalent resistance and we find the value. Other simple way is just connect to ohm meter there and find the resistance. That's way more simple. Yeah, now place an voltmeter across A and B and read the resistance. If R1 is equal to R2 equal to R420, let us consider if R1 is equal to R1, R2 and R4 are equal to 20 and R3 is 5, then meter reads 5, right? Just a basic Ohm's law Ohm's law basic calculations. You can get the meter reads as 5 meters. The resistance across here is 5 ohms. Thevenin's theorem. We call the ohm meter reading under this condition R Thevenin's, like we call this an Thevenin's resistance or R Thevenin's, and shorten this as RTH. We represent it with an RTH. Therefore, the important result are that we can place the network with, like we can now simply place the whole, like as I discussed before, make the whole circuit as this, only one voltage source and one Thevenin source in A and B. This is the Thevenin's equivalent structure. Now this is Thevenin's equivalent circuit. Therefore, the important result we have arrived at this here. We now tie network 2 back to the now before which we consider network, right? Even network 2 consists of many like circuits. Consider now tie with the replaced by Thevenin's equivalent circuit. We can now make any calculation which is with network 2 and then we give the same result if you still have network 1 connected. Now you can find any desired value from the network 2 by using this the equivalent circuit, Thevenin circuit, any desired value in the network 2. Yeah, it follows it could be replace network 2 with then Thevenin's voltage and Thevenin's resistance. The result would be this, be sure, like if you can make the same procedure to the network 2 and you can get VTH2 and RTH2. The network system of figure replaced by Thevenin's voltage and resistance. Yeah, now let us solve an example to find VTH and RTH. Like anyway theory will be over. Let us solve an example that so you can easily understand how to find Thevenin's voltage and resistance. Find Vx here. They asked Vx by first finding VTH and RTH to the left of A and B. So they given a point. So they given a R point and B point. We have to, our task is to find V of X by using Thevenin's Thevenin's theorem. Like they gave 30 volts and 12 volts resistor, 4 volts resistor, 6 volts resistor, 2 volts resistor. Now we should find Vx by finding VTH and RTH to the left of A and B. To the left means here this side. By finding VTH and RTH, we should find the Vx. This is the problem given. Now let us divide. Now let find the VTH particular point. Just open the circuit there. Then we can open the circuit open the circuit there. And you arrive this situation. For finding VTH, for example, VTH. Plus 6 plus 2. Yeah. Consider the circuit for finding VTH, for example, at the left means here anyway it is short circuit, right? Here the voltage stops at here. The voltage exists at this point and this point. So finding at this point voltage gives rise to VTH, right? Now VAB is equal to, according to the according to the current law, we can give VTH is equal to 30 into 6 divided by 6 plus 12, right? 30 into, like we should current divide rule, like voltage divide rule. This is the basic definition of voltage divide rule. Then you can get VAB as 10 volts. Notice there is no current flowing in 4 resistor. There is no current flowing means the voltage in 0. Here the whole VTH only appears between this point. VTH we got it as 10 volts. 10 volts. So we now deactivate the source, like we got VTH, right? Now deactivate all the sources, like before as I discussed. Deactivate the voltage source with the open circuit, short circuit, and current source with the open circuit. As there are no current sources in circuit, just replace the open voltage. We replace the open circuit and open circuit. We replace the voltage source with the open circuit. When we arrived at the figure, 12 ohm resistance 4 ohm conduct like here. Here we should observe one thing, that this is the circuit which we got. Like we can consider these two are in parallel and this is in series, right? Yeah, absolutely. These two are in parallel, this is series. As we know, to find the uh, equivalent resistance in parallel, we know 1 by R1 plus 1 by R2. Here it will give 1 by 2 plus 1 by 4, which gives rise to 4 into 2 plus 2 plus 4, which gives 4 into 2 plus 16 by 2 into 4. 4 4 4 4 by 2, right? 4 by 12, which means 1 by 3 plus 4. Yeah, this is the 18 by 12 into 6. 6 3 is 3 by 12. Yeah, this is the this is the RTH which we got 12. Like this is the let me clear the screen. See, let us consider this and this are in parallel and this is the series. What is the formula for that? 1 by 12 plus 1 by 6 plus 4, right? What does 1 by 12 and 1 by 6 means? 12 into 6 divided by 18, right? 6 3s. 3 by 2, what is the value of 3 by 12? Just a simple calculation. Wait, let me. 3 by 2, 1 by 4. Yeah, we got it. Yeah, here it's 1 by 4. 1 by R is equal to 1 by 4. R is equal to 4. This value is 4. 4 plus 4 is equal to 8. The whole overall RTH is equal to 8. We got RTH. We got RTH as an 8 here. After having found the Thevenin circuit, we connect this to the load in order to find the Vx. We replaced Vth we got which we got earlier Vh10 and Rth with 8, and now to find the Vx is equal to 10 into 2 plus 8, which we are at 2 volts. Now we found the Vx with Thevenin's voltage as 2 volts. Yeah, that is the Thevenin's theorem. Depend for the independent circuits. We even have dependent. Remember, the point is Thevenin's theorem is only limited to for the linear circuits, not for the 3D circuits, non-linear circuits. It's dependent only for Thevenin circuits, and it can be dependent or independent. For the time limit, we are not discussing about the independent sources. As just as given example, basic with the not dependent sources. This is again you can see this RTH is like you can read this slide. This is basic definition of the answer. Now let us discuss the Norton's theorem. Assume the network closed with below is composed of dependent sources and resistors. Difference between the Thevenin's and Norton's is Thevenin's mostly deal with the, if you have more number of voltage source, then consider Thevenin's. If you have more number of current sources, then consider Norton's theorem and try to solve the problem. Anyway, you will get the same answers. But if you have more number of voltage sources, then go with the Thevenin's. If you have more number of current sources, go with the Norton's theorem. As you can see, this example. Consider the network which are connected by Norton's theorem states that network can be replaced by current source shunted by same before like Thevenin's theorem. We just replace the voltage source with the like before which you did with the voltage. Now do it with the current sources. But in Thevenin's theorem, we found that the current voltage source and resistors are in series. Here it will be in parallel. Make sure that current and resistor and IR in parallel. In Norton's circuit, the circuit source is short circuit of the network. This is like you can see. Yeah, in Norton circuit, the current source is the short circuit, that is current obtained by shortening the output of the network. The resistance is the resistance in looking into the network with all the sources deactivated. Just deactivate all the sources which I discussed before, and now make sure the circuit consists of only one current source and the voltage resistors which are in parallel. Now we recall the following from the source transformation. Like Thevenin series will be in series, here it will be in parallel. That is the basic assumption, not the property. The view of the above, if we have the Thevenin circuit network, we can obtain the Norton equivalent by using the source transformation. However, this is how normally go with finding Norton equivalent circuit. Yeah, find the same like now let us consider example and try to solve it. Now find the Norton equivalent circuit for left of the terminal of AB. Here they given AB. Find connect the Norton circuit load and find the current flowing through the 50 ohm resistor, and also find the current flowing through. We should find the using current flowing through the 50 ohm resistor, the Norton's theorem. Yeah, as I discussed, just make sure it in the line. Yeah. By applying Thevenin's to like same doing, we'll get an approach of ISS current flowing through then 10.7 ampere. Now consider another example. We can show in the figure Rn 55. Rn as 15, the same value given for the Thevenin, and the load is shown below. And this is the falling. You can do the procedure like this. It's not in my control. Yeah. This is the circuit here. These are for the dependent sources here.